In this lesson, we're going to be solving exponential and logarithmic equations. This is section 8.5 in the Algebra 2 book. First, we're going to start with some log equations. Now, it's very important that you understand that if you have an equation that starts with the word log in it, then the idea is to get rid of the log at some point in the equation. If you don't have an equation that starts with log in it, like it's an exponential equation, you're going to have to use a log at some point in order to solve it. Okay, so if there's no log, you want to use one. If there is a log, you want to get rid of it. So here we're starting with some equations where they have log in them, and our goal is to try to get rid of the log. Okay, now the first thing I want you to notice on number 1 is that we have a plus sign between two logs. In the last lesson we learned that a plus sign between two logs means you can squish those together by multiplying. So we're going to squish them together to make log base 4 of 9x. When we squish them together, they multiply. Log base 4 of 9x is now equal to log base 4 of 18. Now I want you to notice that you have log base 4 on both sides of the equation. They'll cancel each other out, and when you do that, we have 9x equals 18, so divide by 9, and our final answer is that x is equal to 2. Alright, look at the next one. First thing I want you to notice is that you have a minus sign between your two logs here. And what does a minus sign mean with logs? We can squish them together with division. So we're going to start by squishing them together with division, saying log base 2 of x plus 2 being divided by 3, and it's being equal to log base 2 of 6. Now that you have log base 2 on both sides of the equation, we can cancel them out. And we're going to solve this equation. X plus 2 divided by 3 equals 6. Multiply the 3 times 6 to get 18. Subtract 2. Final answer is x equals 16. On number 3, we're still going to start with using that property that we used just a minute ago on number 2 that says that when we have a minus sign between two logs, we can divide. So the first step for number 3 is take the x plus 6 and divide it by x minus 1. So log base 2 of x plus 6 divided by x minus 1 equals 3. Now I want you to stop for a minute and look at this example, because this is different than the first two we just did. This is different because we don't have a log base 2 on the right side of the equation to cancel out with on the left side of the equation. So instead of canceling it out, we're going to rewrite this problem without the log in it. What is your base in this problem? 2. The base is 2. So to rewrite this, I would say 2 to the power of 3, and it equals the fraction. 2 is my base, 3 comes to the left side, the fraction goes to the right side. This is how you rewrite something without a log. It's called rewriting it in exponential form. Now from here you want to say, okay, 2 to the third power, that's 8. So my next step is to change that to an 8. Now we're going to take the x minus 1 in the bottom of the fraction, we're going to multiply it over to the left side of the fraction. Distribute the 8 to get 8x minus 8. And now we solve this equation. Subtract the x to the left side, 8x subtract x would be 7x. Add 8 to the right side to give us 14. Divide by 7 to give us x equals 2. Final answer. Okay, you try this one. It's very similar to the last one we just did. Pause the video until you're ready to go over it. Alright, the minus sign means that we're going to be dividing these two logs together, as squishing them together as one log. So log base 6 of 7x plus 10 being divided by 2x minus 5, and it equals 1. Now we don't have a log base 6 to cancel out on the right side with the 1 on the left, so what we do instead is we rewrite this. Your base is 6, the 1 comes over to the left side of the equals, the fraction goes to the right side of the equals. 6 to the 1 equals 7x plus 10 over 2x minus 5. Now 6 to the first power is 6, so we're going to go ahead and change that. We're going to multiply the 2x minus 5 to the left side of the equation to get rid of it from the fraction. Distribute the 6 to get 12x minus 30 equals 7x plus 10. And now we solve this equation. Subtract the 7x from the 12x to get 5x. Add 30 to 10 to get 40. Divide by 5. Final answer is x equals 8. Okay, on the next couple problems we move on to exponential equations. These are equations that do not have a log in them. They're exponential equations. We're going to put a log in them in order to solve the problem. So if there is a log, we get rid of it. If there's no log, we need to add it in to use it. First, on number 5, we're going to identify what our base is. Here our base is 2. So to rewrite this with a log, I'm going to say log, and 2 is my base. Bring the 4 to the power of 3x plus 1 to the left side of the equation. Move the x to the right side of the equation. Now take that exponent of 3x plus 1 and we're going to move it out in front of that logarithm to get it out of the way for a minute. Now we're going to identify what this log is. Log base 2 of 4 can be evaluated in our calculator. We go to our calculator, we type in log of 4 close parentheses divided by log of 2 close parentheses. We get an answer of 2. That's evaluating that log. Distribute the 2 to the 3x plus 1 to get 6x plus 2, and it still equals x. And now we're going to solve this equation. Subtract the 6x to the right to give us negative 5x. Divide by negative 5 to get negative 2/5 equals x. You can keep it as a fraction, or if you like decimals, it would be negative 0.4 as a decimal. Alright, on number 6, we're going to identify our base. Our base here is 5. Using a logarithm, we'd say log base 5 of 25 to the third, and it equals x minus 3. Once you identify your base as 5, bring the 25 to the third to the left side, move the x minus 3 to the right side of the equation. Now we're going to evaluate this log in our calculator. Type this into our calculator as log of 25 to the third, close parentheses, divided by log 5, close parentheses. When you do that, you get an answer of 6. And to finish this off, we add 3 to get a final answer of 9. Alright, in the next one, we are going to solve this exponential equation, but before we rewrite this with the word log, we have a step to do first. See if you can identify what the first step would be for number 7. First thing we're going to do is we're going to add 5 to 12 to get 17. And now after we do that, we're ready to go ahead and write this as a logarithm. What's our base? 4. So we're going to say log base 4. 17 comes next to the left side of the equation. X plus 2 goes to the right side of the equation. Oh, timeout. There we go. Now we're going to take our calculator and we're going to evaluate this logarithm. Log of 17 divided by log of 4. That gives us 2.04. And that's equal to x plus 2, so we're going to subtract 2 from that to get 0.04 for our final answer. Try number 8 and see if you can do this without my help. Number 8, we're going to start by subtracting 6 from 15, that's 9. So we have 3 to the power of x equals 9. Now you're going to rewrite this with a log. Your base is 3, so log base 3 of 9 equals x. Evaluate this log in your calculator as log of 9, close parentheses, divided by log 3, close parentheses. 2 is your final answer. Alright, last two. We're going to rewrite these as logs. On number 9, your base is 2, so we'll start by saying log base 2, bring the x to the left side of the equation, move the log base 2 of 3 to the right side of the equation. Now notice, just like on number 1 and number 2 of our examples, we have a log base 2 on both sides of the equation. They'll cancel out, and we're done. X equals 3. So this one looked really difficult, but was extremely easy. Try number 10. Your base is 4, so we're going to start by saying log base 4, move the x to the left side of the equation, move the log base 4 of 15 to the right side of the equation. You have log base 4 on both sides, that'll cancel out, and x equals 15. So these last two were extremely easy, even though they look very complicated and very difficult.